Hello PLFs, this particular additional material refers to an experiment that I showed during lecture 3, in which we had a bottle and some salt solution was put there. On top of that some water was there. There was a density gradient. We sent a laser light which made a turn, and the path of the light was curved. This is in fact a kind of mirage. In mirage, in deserts, the ground level is hot, so air there is rarer and refractive index is less. As you go up, refractive index increases, and because of that, if light comes from top, then somewhere it becomes horizontal and then makes a turn and goes up, giving you a false mirror type or reflection type images of different things. Here in our bottle we had more refractive index at the bottom, salt solution with a larger concentration, and as we went up, this concentration was decreasing, refractive index was decreasing, and therefore it was an inverted mirage. We sent our light from below, it went up, it curved, became horizontal, turned and then came back. So essentially it is a mirage in the bottle. Why does this turning takes place? I had given a post much earlier, had 75 replies on that, and almost everyone wrote the reason as total internal reflection, and 2-3 people did not mention the cause, they had some other comments. Now there are certain issues with this explanation of a total internal reflection, and that I want to raise in this additional material. So the first issue is that total internal reflection takes place when light goes from denser medium to rarer medium and the angle of incidence is more than the critical angle. So what is that critical angle? If you have a separation surface here and you have a denser material here, optically denser, that means more refractive index, and rarer medium here. So this is, let us say, N2 and this is, let us say, N1, and light goes like this, and this is the angle. So we say that sine of IC, this is the critical angle, should be equal to N2 by N1. This defines what is the critical angle, and if this angle of incidence is more than this critical angle, nothing goes out, nothing is refracted, everything is reflected. So that is how the TIR, total internal reflection, is defined. Now the first question is, what is the critical angle in our case, or what is the value, how much is the critical angle? Because in our case the layers are horizontal, each layer has a refractive index, different layers have different refractive indices, but when light falls, let us say here, light falls here, and I am more interested in the part where it is becoming horizontal. So if light falls here on this particular thing, what is that N2 and what is that N1? There is no discontinuity. This N is changing, N is increasing or N is decreasing smoothly with this direction X, you can call this direction X. So the N, the refractive index, does not have any discontinuity. So any layer if you take and then just this side of the layer and just that side of the layer, N1 and N2 are same. So if they are same, then sine IC will become 1. If N1 is equal to N2, and this is because continuous variation, There is no discontinuity, it smoothly changes. So you have n1 equal to n2, sin IC should be 1 and therefore IC should be 90 degrees. So the first problem is, what is that critical angle and when the angle of incidence can exceed that critical angle. So that is the first part. Now the second part is, even if there is some critical angle and even if light does find that the angle of incidence is more than critical angle and TIR takes place, total internal reflection takes place, but when this reflection takes place, it follows the laws of reflection. So this angle of reflection is equal to angle of incidence, I is equal to R, even when it is total internal reflection. So if my light has become horizontal, at that time the angle of incidence is 90 degrees, and if I is equal to R, so we have laws of reflection, so I must be equal to R, angle of incidence should be equal to angle of reflection, and therefore R should also be 90 degrees. And angle of reflection 90 degrees means it is going along that layer, it is not bending. So that is the second question, that I equal to R must be obeyed. And if this is obeyed and I is equal to 90 degrees, I am talking of the portion where this light has become horizontal in our bottle. In our bottle we sent a light like this and then it became horizontal and then it turned. So I am talking of this topmost point where the angle of incidence is 90 degrees, it is going parallel to the layer. So if I is 90 degrees, that implies R is also 90 degrees, and that means it must proceed parallel to that layer, it should not go back. So that is another problem with reflection analysis. The third question which I can raise is that when it is going in horizontal direction, there is more refractive index below and less in refractive index above. How do you say that it is falling from the denser medium to the rarer medium? Remember, you have n which is increasing downward, n is increasing downward, so that's fine. So you have this. Now if something is going this way, how do you say that it is falling from this side on this side and not from this side on this side? Symmetry. How does this ray can be treated as falling from the denser side on the rarer side and not from rarer side to the denser side? We can very well say that okay, it's falling from this side to this side, in which case there cannot be any TIR. So that is another question I can raise. How does the ray which has become horizontal know whether it is falling from denser layer? Denser means optically denser, remember, from denser layer to the rarer, or reverse, or vice versa. The previous history is something which we don't need. We cannot talk of that. In the past it was coming from denser side and all that. At this point what happens when it has become horizontal? It's not a hysteresis that the previous history will decide the future. It's not that. So at this point, the situation is like this. And in this situation, you cannot say whether it is falling from here to here or it is falling from here to here. So please think on these questions and work out if you can do away with the reflection hypothesis, and can you explain that bending purely on the basis of refraction and the Snell's law.